Okay, we're going to continue with the solution for problem 9 out of the Evans book, chapter 2. This is going to be the fast version, under 10 minutes for the solutions that are within this. What we need to find are the row numbers corresponding to the first and last instance of item 1369. So we're looking at column C here in 1369, you can see on the screen. And we want to find the first instance and the last instance, and specifically the row number. That's what we're going to use match for. We're going to try to find these indices into a table. So first thing is get the first instance, use the match function. First item will be the term we're seeking on. Then we'll add in the range that we're after. We're going to end up copying this over, so I'm going to convert this to absolute using the F4 command, which very quickly converts that to absolute form. And we're going to use 0 to specify, just find the first one, and we're done with it. Hit enter, and we should have found that the row number is row 12 in the data range that we talked about. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's reference to the start of the data range that we used. So now we have to find the last instance. We'll copy that over again. This is why we used absolute. And what we need to do is find the last instance here. Now this is the way this command works. We're searching on 1369, and when we say using the term of 1, we're going to say less than or equal to. Okay, so this time we're going to specify with a 1 here, and that's going to change the behavior of the match lookup. And what it says is using the 1369, and we're specifying conditional less than or equal to, it comes down the list while it's still satisfying. 1369 does not satisfy any of these to begin with. It's larger than these. It finds 1369 but keeps searching because we said less than or equal to, and it comes across 3166 and stops because it's now less than 3166. It backs up 1 to the 12th line. So you're looking for the last instance of this in the sub-range of our data here. So we solved the first part, 9a, as in the 12th and the 14th row of our data. Okay. So B says find the order cost associated with the first instance of item 1369 that you identified in part A. So all we're going to do here is find we look under the cost per order. This is what we're looking for, the order cost here, and our range is we have 3 entries from 63,000, 58,000, 42,000 here, and we just want to bring back the dollar value associated with the first instance. Okay. So we're going to use the index function, and we need to give it a range. Okay. A little bit of freedom here. And grab all the data. And we're going to convert that over to absolute by using F4. And now we need to give a row and column. So we know we have some rows involved, so we'll use a matching here. And we're going to want to have column 7 because it's 1, 2, 3, 4, 5, 6, 7 rows over. On the match, we're going to go search again for our 1369 data range once again. And we're looking for first, so we put 0 in as the attribute there. And with that, we should be able to get the number $63,000. Okay, so we just solved part B, was find the dollar value associated with the first order, 1369. So now we have an interesting part here. The total cost of all orders for item 1369, we know there's 3 orders in there for 1369, and using the parts from A and B along with the sum function. Okay. So we want a total dollar value for all the 1369 orders. So we know it's going to be a sum, and the sum wants a range. So range is separated by a colon. Let's get ourselves prepared. We can put down milestones here as we start building our equation out. So we need to have the cell number for the first instance here, the 63,000. And we're going to do a long form here just for the practice to show. So we're going to return an index here, and we're going to return another index here. That's the format for a range. Okay. And the first index, we need to specify the range, so we'll specify the range. Using all the data, and that we'll have filled in. And we're going to make that absolute, because we might borrow that in a second to do it quickly. So that's the data range we want. The row that we want is told by match, which, doing it long form here, 1369 is what we're after. The data range we want, we'll make that absolute. And we want the 0 in there again. Remember, we want to start at the beginning and end at the end. So what we've got in there now is an index function that's going to return a cell number. We're going to look in this range. The row number is given by this match, and the last parameter is the column. So we put in the column. Okay. Now we know the second element here is going to look considerably the same. So we're going to borrow all this. The only thing that really changes is how we're going to do our search. That's why I use the absolute cell numbers in here. And all we need to do is change this to a 1. And we should be able to sum up all those lines. And if we go back to the solution, the actual solution, we can see we indeed found $163,800. That's the proof in the solution. If you want to format it, just change it to dollars. Looks good. And now it looks the same. Okay. The only last part of this said, validate your results by applying the sum function directly to the data in column G. So we kind of did it the hard way first, and now we're just going to say simple sum. And we're just going to say equals sum of the lines that we need here will be these right here. Finish that off, and we've proven it, 163,000. That's it. That's all you really need to do. And if you understand match and index, I know I went quickly here, but that should show you how to build these equations up.